Okay, I was just going to work out number 29 from the homework from beginning to end. And I'll, on the calculator part, we'll definitely kind of look at that a little bit closer. So, how many years will it take 8,000 to grow to 12,400 if it is invested at 3%? So, looking at compounded quarterly, so that'll be part A. And so our formula is so we want to know our accumulated value, which they tell us, which will be 12,400, and then our initial principal is 8,000, and then we have to multiply that by one plus my rate of return, which can be 0.03. That's the 3% right there, divided by the number of times we're going to compound it in a year, which will be 4 since we're quarterly, and then we're going to raise it to a power of time times the number of times it's compounded. So that's going to be 4 times t, our time right there. Okay. Now, uh, I know you told me in your email that you kind of looked at view the example. I might be doing this a little different than they do it. It's probably the same, but it might be a little different. But so what you want to do here first is isolate the base. So we're going to divide by 8,000 on both sides. So we'll divide by 8,000. And as far as reducing here, you can. If you don't, it's not really a big deal. I'm going to go ahead and reduce it a little bit. I'm going to cancel out those zeros on the back end right there. And I could reduce it further. I'll probably just go ahead and leave it like that, though. So 124 over 80, because that's going to get put in the calculator in a minute anyways, um, equals 1 plus 0.03. Oops. Let's see. 0.03 divided by 4 raised to a power of 4t. Okay, so at this point, what we have to do in order to get that exponent, um, get it down, what we're going to do is I'm going to take the natural log of both sides. So I'm going to do ln of this side and squeeze it in right there. So I'm taking the natural log of both sides. Now, what that will allow me to do is it's going to let me bring the 4t out in front right here. And so I'll go ahead and write that up here. So let's see, we're going to have natural log of 124 over 80, and then equals 4 times t times the natural log of 1 plus 0.03 over 4. Just was able to squeeze that in there. Okay, and then we're going to go ahead and uh, divide both sides by the 4 and then by the natural log of 1 plus 0.03 over 4. So divide by 4 times the natural log of 1 plus 0.03 over 4. And so what that will do here is it will isolate the t value. And I think that's kind of where you were in the email with me. You kind of presented it a little different. You had the subtraction instead of this quotient right here, which is the same thing. It's the same thing. But you do have to be careful with how you put this in the calculator, and it kind of depends on what calculator you're using. And so the calculator I have here is it's old. It's a TI-83. Um, but the way I'm going to show it to you, I'm going to do it in little steps. You could potentially type this whole thing in the calculator and all at once, but there is a potential to making mistakes if you do that. So what I'm going to do here, and I'm going to go ahead and figure out what the natural log of 124 divided by 80 is. Okay. And on the one you sent me, you could go ahead and do your log or natural log. It doesn't matter. I picked natural log. I could have picked log, by the way. But you could go ahead and do the numerator. So go ahead and do the numerator separately. And you get that answer right there. So I get that result. Now, what's nice about the calculator I have is that I could actually go ahead and say divide, and it'll take my answer. Now, when I'm dividing, I actually have to put a parentheses, and I'm going to have to go ahead and put the 4 times natural log, and then I'm able to type this whole thing in right here. 1 plus 0.03 divided by 4, and then I got to close that parentheses and then close the original one that I opened up here where I was dividing my answer, right? Divide my answer by 4 times the natural log of 1 plus 0.03 divided by 4. And so this is going to be my answer right here. It's going to be 14.66. Let's see, they said round 2 decimal places, so 14.66. So I don't know, I don't know what calculator you're using. If you're using a scientific calculator, you might have to break it up even more. And what you'll have to do is figure out the numerator, natural log 124 divided by 80, close it. And you might have to write that down on a piece of paper. And you're going to want to write that down, at least I'd say 5 decimal places just to be safe. And then to figure out the denominator, you might have to, figure out what is the natural log of 1 plus 0.0. Well, depending on what calculator you're using, you might have to actually even figure out what 0.03 divided by 4 is. Okay, and then add 1 to that. So then you add 1 to it. And so now I know what is inside here. I know what's inside there. And so now I could take the natural log of 1.0075. So I could figure out that part of it, right? And then let me write down what the top is. Remember I said I was going to do a couple decimal places. So let's see, 0.43825. Okay, so that's 5 decimal places for the numerator. And then my denominator, I figured out what the natural log was, but now I need to multiply that by 4. So I'm going to go ahead and put times 4. And so my denominator would be 0.2029 and then a bunch of 8s. So let's see, 0.029 and then a bunch of 8s. And so, to be safe, the more decimal places, the better. And let's see if we come up with 14.66 also. Hopefully we do. So let's see, 0.43825 divided by 0.029888. Let's see what we get. Okay, there we go, 14.66. So yeah, so you can kind of see how I broke it into smaller little steps, and just kind of depends on the calculator you're going to be using. And by the way, it would be the same if I would have done the log of both sides. If those would be log base 10s instead of natural logs, it'd be the same thing. And so while we're at it, we can go ahead and look at the part B where it's compounded continuously. That one's actually a lot easier. That part B right there is actually a lot easier. So let's see, our accumulated value, accumulated value would be 12,400. And then this time the formula is going to be your principal times E raised to RT. So that's going to be 0.03 times time. So the formula here is going to be a little bit easier to work with. So we'll do the same thing to get started. I'm going to keeps jumping on me. We'll divide both sides by 8,000 to get started. And once again, I'll just go ahead and cancel out the extra, we'll cancel that out completely. Cancel out the extra zeros right there, just make it a little bit smaller. So let's see, 124 over 80 equals E raised to 0.03t. Now this one's going to be a lot easier because when I take the natural log of both sides, I can use the property of logs right here. Whenever your natural log is base E, whenever it matches what you're evaluating right here, that will just cancel out to the power right there, the exponent. So I end up with natural log of 124 over 80 is equal to 0.03t. And so the last thing we'll do is we'll divide by 0.03, 0.03, cancel that out, and let's see, we'll go ahead and put this in the calculator. So let's see, we're going to have natural log of 124 divided by 80. And by the way, it shouldn't make much of a difference. It will make a little difference that you're compounding continuously. I still think it'll probably be around 14 point something years. Let's see. So, and then we're going to divide by 0.03. And so, yeah, I mean, it's 14.61. So it doesn't make a huge difference, but I mean, it does a little bit. So, okay. So I hope that helps. If you need anything else, feel free to email me.